The sine is the y value. Okay, I gotta turn that silly sound off. So right here, the y has no, it's 0. So the sine, by the way, this is theta, not x. It is the angle. So why did I not have a cursor? Stop. Put that down. I don't want that. Yeah, never. It's technology. Does it ever work for me? Okay. As we move around this way, the sine value gets taller and taller and taller and taller until it gets to 1, right? If I took those little sticks and I moved them over here, it's getting taller and taller and taller and taller until it gets to 1. Now what's happening to the y value over in this quadrant? It's still positive, right? But it's getting shorter. Okay, if I could draw. So I still don't have a cursor. Urgh. Seriously? What is going on? Well, it would help if I could tell where I was going to write, yes? Okay, these are getting shorter and shorter and shorter. Not like that. And I get down in this quadrant, and what happens to y? It gets negative, but it's very small, right? And then it's getting more negative and more negative and more negative and more negative. So if I took those little sticks and I moved them over here, badly drawn, it would look like that. And then when we rotate around into this quadrant, they start getting shorter again, but they are still negative. Okay, if you remember, this is the shape of the sine function. It goes through 0, 0. And what did we do? It went all the way around until where? One rotation, which is what? 2 pi. So this measure of theta was 2 pi. So where did it switch from green to red? At just 1 pi, right? Right here we switched. It hit its maximum value of 1 right here at what value of theta? I don't know why this isn't. This is pi over 2. And it hit a value of 1. And what was this one down here? Do we know the unit circle enough to know what that's called down at the bottom? 3 pi over 2. And it was hitting the minimum of -1. Now, I've drawn one period. It actually repeats over and over and over and goes on forever. So is this an even or an odd function? Does it have origin symmetry or does it have y-axis symmetry? It's origin. It's the same upside down, so it's odd. Oh, you finally got one, Miss Abruzzo? Oh, you didn't get one. Everybody good? Any questions? Let me go back to this real quick and just show you. It's tracing out the green shape over here is the green. Do you see the green on this picture now? Made the sine graph, okay? If we talk about cosine, then we're talking about the x value. What is the x value right here? 1. And what is happening to the x? Can you see the blue number down there? It's getting smaller and smaller, but it's positive. So the x value over here at 0 is 1, so we're up here at 1. Then as we move around, the x going this way is eventually getting shorter, yes? Now, because of the way we're graphing it, this is theta, and this is the cosine value. So we're going to take those sticks and we're going to actually plot them up and down as we're graphing that, and it's getting smaller. I didn't do my sticks very good. And then what happens when we switch over past pi over 2? We switch into this quadrant, we get x is now what? It's getting longer, but it is negative until it gets to -1. If I could draw. And where does it get to -1? Yes, this is pi. Okay, then it goes, it's still negative, but it's getting what? Shorter. I did a little bit better job with those sticks. And what is that point where it changes here? 3 pi over 2. And what does it change to? The x values are now short, but they are positive and getting longer. All right, if we were to draw this over and over and over, what kind of symmetry would this have? Do you see right here it has y-axis symmetry? So it is an even function. Now, do you get that one is just a shift of the other? They're really exactly the same function, but they're shifted over, okay? So they are called sinusoidal functions because you really could write every one as a function of sine if you wanted instead of cosine. Cosine graph is really a shifted sine, or a sine is a shifted cosine. All right, we are not going to talk about tangent today because we are going to move on and talk about the amplitude changes, vertical shifts, and period changes, okay? Basic sine graph, okay, is odd. It goes on forever. It has an amplitude of what? Does anybody know what amplitude was? Did you watch the video? It's actually the stretch above and below, yes. So it would be called a vertical stretch, okay? It is half the distance between the max and the min. I think you all understood that as you were saying it, but we weren't all saying it the same way. It's how far above and below the midline it goes. That make sense? Okay. The amplitude, by the way, this is important, is always what kind of a number? Positive. Okay, it says the absolute value of A is the amplitude. It's always positive. All right. And the amplitude is found in the equation right out in front. It's what's multiplied, vertical stretch, always multiplied by the function. All right, the second thing here is period. The period is how long it takes to complete one cycle. So the period is the length of one cycle, or the amount of time, if we're reducing time, to go around once or complete one rotation. When we do Ferris wheel problems, how long it takes to go around is going to be the period. All right. Now, the period is actually hidden in the equation because the normal period is not 1 anything, right? The normal period is 2 pi. So the period is changed. It's 2 pi normally, but it is changed by dividing by b, whatever that inside stretch is. And we will, in this class, we will practice pulling that out and writing it like this. So the b is going to be here, what's multiplied by x. And it honestly doesn't matter if you pull it out or don't for the b. Okay, it's still multiplied by x. But remember, the period is not just b. Okay, so amplitude, if you wanted, you could find the difference and divide by 2. Period, you have to take 2 pi divided by b to get the new period. We're not going to worry about frequency today or phase shifts. We are going to do vertical shifts. The midline is affected by what's added or subtracted onto the back, and it moves the maxes and mins up or down. It is a vertical shift, which we'll also call the midline, okay? So here, this was the midline, all of these D values. We're not going to have a C value for today. All right, no C values yet today. We'll wait till after the quiz next week. All right, this is an important slide. It says to graph a sinusoidal function like this, where you have a period change, you find the period of the function, and then you add on quarter points. You have to do quarter points for this class. And you take the period divided by 4 to figure out how far you're adding on. So when we get into some funky period changes, okay, you're adding the period divided by 4 to find quarter points. Quarter points means a fourth, right? A fourth of the period. Okay. No decimals. Ready to try this? I don't know. What do you remember? Okay. Y equals cosine theta was what shape? Is that the one that starts up or starts at 0? Yes, it is an even function, so it starts at the maximum. So that's the shape we're going for. What is this 2 doing? Yes. So the maxes and mins are going to be at 2 and -2, because there's no vertical shift, right? There's no midline change. That's always what we do first. So this is no midline change, so this is the 0 here. And this would be theta, and this would be y. What is this number doing, though? First of all, it's painfully written, in my opinion. Most of you would be better with 2 cosine 1/4 theta. Is that everybody good that the b is really 1/4 because it's divided by? So if b is 1/4, it is changing the period. But remember how anything in the parentheses does the opposite of what it seems. The 1/4 doesn't actually make it smaller. It's going to do what? It's going to make it horizontally stretched. So we're going to do 2 pi, the normal period, divided by b, which is 1/4, to find our new period. Well, how do you divide fractions? Multiply by the reciprocal, so 2 pi times 4/1 becomes 8 pi. So this thing has a period of 8 pi. Now, I am a horrible drawer. I can't draw. It's going to be bad. I'm just telling you now. But I don't label the period until I'm done. I just draw one cycle and then I figure out how to label it. So it's starting at the max because it's a cosine. It goes down. Oh my goodness, that's horrible. They should kind of all look like quarter circles. Quarter circle, quarter circle, another quarter circle, quarter circle. I don't know. I'm going with that. Are we good? Okay. So what is this end point labeled? Did we decide right back here? We said that is 8 pi. Whoops. What is that? Not even going to try to justify that. Okay. 8 pi. So this ordered pair is actually 8 pi over and 2 up. Okay, so help me out. What's halfway? If we divide the period by 4, our quarter points are each going to be, these are our quarter points. So 2 pi, 4 pi, and 6 pi. So the ordered pairs real fast. This one is over 0 and up 2. This one is 2 pi 0. 4 pi -2, 6 pi 0. On a test or quiz, you have to label them, or you have to write me a little list of those points over to the side if you can't fit it on your graph. Is that making sense? On your homework, if they're like right on the 0, do you know what I'm saying? And you don't write the order pair, that's fine. Just so your axes are all labeled and everything, okay? But if they're weird, like 1/3, 1/6, 2/3, whatever, make sure you label them so you can figure out what they are. But you don't have to write it 3 different places, I guess is what I'm saying. Can you try this one on your own? How far can you get? Amplitude? Period? The B is 2, but the period becomes what then? 2 pi over B. So it's pi. Before we graph, though, what's the shape? It's going to start, yes, at the midline, which, does it have a shift up or down? Nope, so the midline is just 0. Okay, what does it mean of amplitude 3? The maxes are at 3 and the mins are at -3. But you said it starts at 0, 0, so I should start here. Up, down, ooh, back up. I didn't go down far enough, but we'll pretend. Big dot, big dot. Okay, label my ordered pairs real quick, somebody. What's this last one? Over pi and up 0, because we had to divide 2 pi by 2 to get a period of pi. So halfway, when we divide that by 4 to get the quarter points, right? Pi over 4. So this is 1 pi over 4. You could write 2 pi over 4, but eventually you need to reduce that to what? Pi over 2, and then this one is 3 pi over 4. All right, so we had 0, 0, pi over 4, 3, pi over 2, 0, 3 pi over 4, -3, I'm cheating here, and pi 0. Good enough? Any questions? Seems okay so far? All right, number 3. Ooh, we have not talked about that negative out front. What does that negative do? Remember what a negative x squared graph looked like? Yes, it's reflected over the x-axis. So a negative cosine graph, the shape, instead of normally starting at the max, it's going to start where? At the min. So this is the shape we're looking for. It's a negative cosine. Other than that, once we think about that negative, what it does to the graph, we ignore it because the amplitude is actually what? The 1/2. It's not negative. Amplitude is always positive. The B value is 3, so that makes the period what? 2 pi divided by 3. It's always 2 pi divided by whatever B is. Okay, the quarter points are going to be interesting. 2 pi over 3, we need to divide that by 4. What does dividing by 4 do? Multiplies by 1/4. What is 2 pi over 12? Pi over 6. So that's what we're going to count by for our quarter points. It's always 4 because they're quarter points. Quarter, 1/4 of something. To find out, you take the period divided by 4 to get the quarter points. Do you need to write that somewhere? Period divided by 4 is the quarter points, okay? All right, so quick sketch. It starts here. No, it doesn't. It starts where? At the bottom. Wait, it's supposed to be 1/2, so I'll try to make mine a little shorter. -1/2 to +1/2. Starts at the bottom, and it's actually pretty small in general. It finishes by 2 pi over 3. I don't care what you use for your scale so that you can make it work for you. If it's stretched out and it's really not supposed to be, whatever. This is 2 pi over 3. So this was 0, negative 1/2. And this is 2 pi over 3, negative 1/2. So we got to go back and count by pi over the quarter. We had one in between here, and this one, and this one. My graph is stretched kind of funny, always. Some of you know what that middle one is because it's halfway to 2 pi over 3, which would be 1 pi over 3. But otherwise, just count by pi over 6s. The first one should be pi over 6. The second one is 2 pi over 6s, which would be 1/3 when it reduces, right? And 3 pi over 6s, what's 3 over 6? 1/2. And you could write those down. You could write pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and then go back and reduce them if it helps you to write it out. All right, do I need to label them or are you good? I'll just label this one that's not a 0. How's that? Pi over 3, 1/2. The other two are at zeros. Can I just pretend? All right, what's next? Oh, vertical shift. Ready to try a vertical shift? This number that's added on the back, first of all, is not included in the parentheses. It is a vertical change, not a horizontal. So it's up 3. That's going to change the midline to y equals 3. Now, there's two ways you can do this. You can relabel this line right here, y equals 3, instead of y equals 0. I'm actually kind of a fan of drawing the midline up here, but you can just relabel the middle one. And then how far above and below that am I going to go? 2. So where are the maxes going to be if the midline is at 3 and the amplitude is 1? Amplitude is 2, right? It said here. So 3 plus 2 is 5, and 3 minus 2 is 1. Now, again, if you want to just call this midline y equals 3, you just got to be real careful, because when you go up to this is 5 and down to this is 1, so at no point are you going to have any points labeled 0, right? I always mess up if I do it that way, so I actually draw it here and I say my maxes are going to be up at 5 and my mins are going to be down at 1, and I draw myself little guidelines. Okay, we didn't talk about the period yet. What is the period of this thing? There's no change in here, so B is just 1, so the period is 2 pi. So what are the quarter points at? 2 pi divided by 4 would make them pi over 2s. Okay, so we're going to have pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, etc. Where am I starting because it's a sine graph? Sine has a shape of midline up, down. So I'm going to start here, up, down, and I'm done. If you're drawing it counting the shifted midline, same, oh my gosh, that's a horrible graph. Same thing, but shifted, but your shift is taken into account by relabeling that center line or midline. All right, so the ordered pairs, not 0, remember, this is over, well, it is 0, over, but it's up 3. Okay, I forgot to label my quarter points. What are these doing again, going across? It finishes by, so halfway there is pi, pi over 2, and what's the other one? All right, so pi over 2 is up at 5. You don't have to draw it twice. I'm just showing you either way you could do this. This is where somebody goes wrong, because they label this pi 0. Is it pi 0? Because that was 3, right? The midline was pi 3. That's why my way makes it look like pi 3, but I don't care what you do. Then this one is 3 pi over 2, comma 1. It's not negative. It's just 1 down here. And then we hit back up here at 2 pi 3. Okay? I kind of labeled some on one graph and some on the other, but anybody have a question? All right, we got 2 more or 1 more for practice? 2 more? Okay. Describe this one for me. What's going on? The B value is 1/2, yes. So the period is going to be 2 pi divided by 1/2, or 2 pi times 2 over 1, which would make it 4 pi. Is there an amplitude change? Nope, it's just 1. There is a vertical shift down 4, which makes the new midline what? Y equals -4. The amplitude is just 1. It is a cosine graph, so it starts at its peak and returns to its peak in 1 period. Okay. It's shifted down 4, so I'm going to make my 0 up here and go down 4, but you can just label your midline -4 if you want. Okay, if the amplitude is 1, where are the maxes and mins going to occur? -3 is 1 unit above, and -5 is 1 unit below. So it's just starting here. I have a very small graph going. How long until it finishes? 4 pi, so this would be 4 pi -3 when it returns. The quarter points, as every pi, yes, because you're going to do 4 pi divided by 4, which will give you pi. So this is 1 pi, 2 pi, 3 pi, 4 pi. It's not 3 pi 0, it's 3 pi -4, because it's at the midline. 2 pi was at the minimum, which was -5. 1 pi was at the midline, which is -4. So yours might look different in that you didn't shift it, actually. You just relabeled it. But do you have the ordered pairs right? Questions? How many of you think this is pretty easy so far? How many of you think this is tricky? Anybody give me the thumbs down if you're kind of struggling with this. A little bit? Kind of don't remember it, Haley, too much? You're okay? Okay. Second time around for everybody, right? Okay. What else going on here? It is a negative sine graph, right? The amplitude is +3. Yes, don't state an amplitude as a negative. The B value is just 1, so the period is 2 pi. And the vertical shift is, woo, not down 1. Just checking if you're all awake. Up 1. So the midline is at y equals 1. What does a negative sign look like? Starts at the midline, but does what first? Goes down first. Did I mess up anything? Oh, the quarter points. If the period is 2 pi, the quarter points are 2 pi over 4, which would be every pi over 2. All right. You want me to do this one by renaming the midline instead? I don't know which way you're used to, so if you rename that as 1, just be real careful, because that means 0 is down here somewhere. Okay, it goes 3 above that, so the maximums are all at 3. No, they're not. See, this is where I mess up. I can't do this. I like redrawing it. Okay, so 3 above 1 would be 4. 3 below 1, this would be 0, -1, -2, right? Did I do that right? This is a struggle for me because I don't do them this way usually. All right, the shape we discussed was this. I can draw that part. Not well, but I can try. Obviously, they're the same size, the down hump and the up hump, right? Obviously, or not. Okay. This line down here is y equals 0. This is y equals 1. So label these points carefully. This is over 0, but up 1. Where did we end at? The period was 2 pi, so this is up 1. So 1 pi, and we were up 1. What's halfway to 1 pi? Or what are the quarter points supposed to be labeled by? Pi over 2, and this one is down at the minimum, which is -2, because it's the midline of 1. 3 below that would be -2. And then counting by pi over 2s, we had 1 pi over 2, 2 pi over 2, which is pi. This would be 3 pi over 2. And it's at the maximum, which is 1 plus 3, or 4. We good? Now that you're good at those, I got to tell you, look at worksheet 11, because it's a little bit different. Because what's different on 11 is that the graph paper is there, okay? Some of them that's easy, and some of them it's not so easy, right? Because if you don't like the graph paper there and you want to do them on a separate piece of paper because it's easier for you to try not to match their points, that's okay. Do you need me to do one where you're, so you have to do worksheet 11, this is the assignment, guys, label at least 5 points for each graph. Now, I could probably open real quick and look at one just to talk about, like, number 1 is not assigned. I don't know which other ones weren't assigned. Number 1 is assigned? No, this is the, oh, did I circle it? Oh, these are the ones that are assigned. 2, 3, 6, 8, 9, 11, and 13. Oh, gotcha. So 4, 5, and 7 aren't assigned. 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 So I was just trying to see if there was one that we could do. Like 4 is not assigned. So if you're going to actually do the graph paper here, this is the midline, right? Goes 3 above that, so it's going to go up to 4. 3 below that would be -2. And where's it going to finish by if there's no B in here? It's going to finish by 2 pi. So halfway there would be pi. It is a sine graph, so it's going to do what? Start at the midline, go up. See, I don't think these are too bad. The ones that were really nasty, where you had to do thirds or something, I think I actually either relabeled it for you, or I just took the labels off so you could label how you wanted. Does anybody know what I'm talking about? Is there one of those somewhere? On which one is it? Okay. Okay. Like number 8, what is the period on 8? This B is 3, so the period is 2 pi over 3. So it would be real hard to mess with those labels, right? Figure out where you're going. So I just eliminated those so you can label something out here 2 pi over 3. And then halfway there would be 1 pi over 3. Anybody remember what the quarter points are? 2 pi over 3 divided by 4 is 1/4. 2 pi over 12. These are pi over 6s. But do you see what I'm talking about? I left the labels off so you don't have to try to match with their weird ones. Yes. Yes. Okay. I'm going to stop the video too. But there's the assignment again.